So for this chapter, the thermal destruction, so you need to know the thermal destruction is same with the incineration. So incineration is one the options for the waste to be handled or to be disposed. So actually incineration can be used if our materials, or it's not our materials, it's if our waste can be reused or recycled, for cases like if the waste can be identified what kind of waste, the type of thermoplastic maybe. So other than that, maybe the waste is already contaminated, and actually the incineration is better option for this kind of waste. The energy recovered from the incineration can be used as an energy source. For example, the electrical, the mechanical, and the unburned materials will be sent to landfill or to disposal.
Waste grows each year since human population getting bigger and bigger. Therefore, we as a human need to find an alternative way to manage the waste. And one of it is thermal destruction of waste and plastics. There are 8 waste disposal options for this waste. If you guys want to know what it is, stay tuned. Waste disposal option. First, low temperature O2 or air enriched system. Second, steam reforming. Third, low temperature starved air system. Fourth, gasification. Fifth, hydrogenation. Sixth, energy recovery. Seventh, blast furnace reduction. And last but not least, pyrolysis. Okay, in this video, we will tell you in detail about pyrolysis process and gasification process, as well as incineration process, because the 3 process is related to each other. Stay tuned.
A visualization of the biomass pyrolysis process. Biomass storage and drying. Wooden or agricultural biomass stored in a dedicated storage facility is transported to the pyrolysis reactor via a bucket feeder. The raw biomass is pre-dried inside the feeder through the use of hot and dry air flowing in the crossflow. Biomass pre-drying has a positive impact on the reduction of the moisture content inside the process material by a few %, and additionally increases the pace of the processes occurring in the following stages. Biochar production. Pre-dried and preheated biomass then goes to the pyrolysis reactor, where the following 4 processes take place. The moisture evaporation process. All the moisture accumulated in the raw biomass has to evaporate in order to initiate the carbonization process. Depending on the type of biomass and the amount of moisture accumulated in the process material, it can take from several to more than a dozen seconds, and its efficiency is due to the high temperature in the upper part of the reactor. The degasification process. In the next stage, the biomass is degasified in the temperature range of 370 to 400 degrees centigrade, within which range the removal of volatile particles is most efficient. Chemical compounds like nitrogen, carbon monoxide, carbon dioxide, hydrogen, and others are flammable, and approximately 40% of the energy yield is consumed by the pyrolysis process. After mixing with the humid air from the preceding process, the remainder of those gases can be used for energy. The carbonization process. Dried and degasified biomass is treated with high temperature. This process results in the quick concentration of elemental carbon and the disappearance of the fibrous structure, improving its grindability. Depending on temperatures inside the reactor and the duration of the carbonization process, the ready material can have a calorific value in the range of 21 to 29 megajoules per kilogram. The cooling process. The ready material is cooled to ambient temperature with the use of the cross-flow water cooler. In the next stage, carbonized biomass is loaded to big bags, pelletized, or transferred directly to the boiler. Heat generation. The flammable gas has a relatively low calorific value, so the best way to make use of it is by conversion to hot water. Pyrolysis systems with productivity from 300 to 1,000 kilograms per hour can supply district heating networks with a maximum capacity from 1 to 3 megawatts respectively. The yield of flammable gases depends on the type and quality of the processed biomass and the expected characteristics of the carbonized biomass. In order to maximize the efficiency of the pyrolysis process, hot air taken from the coat of the reactor is used in the biomass pre-drying process. Hot air is transferred to the bucket feeder, which was illustrated some time ago. At the end of the process, all gases are mixed and emitted through the common stack.
Hello, I'm Steve, an engineer with the Department of Energy, and I'm going to explain what gasification is, how it works, and how industry uses this process. Gasification allows coal or even dried plants to be transformed into many useful everyday products in an environmentally friendly way by breaking down coal into molecular building blocks that can be reassembled primarily with oxygen and water to make plastic, clothing, gasoline, diesel fuel, fertilizer, and electricity. So, how does gasification happen? Let's start with fire, also called combustion. Wood, like coal, is mostly made up of carbon, hydrogen, and compounds that do not burn, called ash. Air is mostly oxygen and nitrogen. During combustion, oxygen bonds with the carbon and hydrogen, creating a chemical reaction that gives off so much heat it produces fire. The soft ash left behind would have to be carefully landfilled to prevent leaching of contaminants into the ground. Gasification is similar to fire or combustion, but it occurs in a closed vessel. Less air is provided than for combustion, and water is added as steam. Oxygen chemically reacts with the carbon in the coal to become carbon monoxide. The hydrogen atoms in coal become hydrogen gas molecules. The water also provides oxygen to chemically react with carbon, leaving hydrogen behind. These chemical reactions give off heat, but less than if the coal were completely burned. The product of gasification is syngas, which is primarily carbon monoxide and hydrogen molecules. The sulfur in coal becomes hydrogen sulfide, which is separated from the syngas and is used to make sulfuric acid, which is then sold. Due to the high temperature inside the gasifier, slag is made instead of ash. Slag is like small rocks, and contaminants remain safely trapped inside, so slag can be used to make roads. Whereas gasification breaks coal down into small building blocks, other processes not covered here will reassemble these molecular building blocks, hydrogen and carbon monoxide, into all of these valuable products. To make clean energy from coal, we need hydrogen. To make more hydrogen, the water-gas shift reaction can be used to exchange each carbon monoxide molecule for a hydrogen molecule. When syngas is combined with steam and a catalyst, the water molecule gives off its oxygen atom to the carbon monoxide, turning carbon monoxide into carbon dioxide. Catalysts are used to increase the speed of chemical reactions. DOE's vision is to use hydrogen to generate electricity in a power plant with only water going up the stack. Coal can indeed be used to make clean electricity. But gasification is not limited to coal. Wood, natural gas, oil, and farm waste can all be burned to make heat. They can also be gasified to make clean electricity, clothing, fuel for cars, trucks, tanks and jets, and other products we use every day. Clean coal gasification can be done today. DOE is developing technologies to make this vision affordable. To learn more about these technologies and gasification in general, enter Gasifipedia into your preferred search engine.
How's the video? Do you understand? I hope you understand both of the process. If you guys wondering what the difference between these two processes, let me tell you. First, pyrolysis is done under the absence of air or oxygen. Meanwhile, for gasification process, we need a little bit of air or oxygen. Second, the temperature used for pyrolysis process is lower compared to gasification process. Therefore, energy produced for pyrolysis process is lower compared to gasification process. The product produced by gasification process is only fuel gas, which is carbon monoxide, carbon dioxide, hydrogen, and methane. For pyrolysis process, we have two additional of product instead of fuel gas only, which are bio oil and char. These two processes can produce energy which can be converted into electrical energy by turbine and engine. However, for pyrolysis process, we also can use boiler to convert the energy into electrical energy. Can you catch up? If not, never mind. I prepared a slide for you to differentiate between these two processes.
And as you already watched the previous video for the gasification and pyrolysis, after this I will tell you the advantage and disadvantage of these two process, and I'll show you on how to make it the notes become a simple notes, so you can understand and memorize it easier. Yeah, easier. Okay, so stay tuned. Okay guys, so I'm going to tell you about the advantages and disadvantages of gasification and also pyrolysis. So as you can see that this is the notes, the lecture notes that I print out, and it's so many slides. And of course, before you want to memorize something, or for the first time that you read the notes, you actually after you finish read all this kind of notes, you need to take it out the important information and make it short notes like this, because this is my own way to make me understand more or to memorize it easier, rather than read this kind of notes, because there's so many slides here. Okay, so for the advantages and disadvantages of the pyrolysis and gasification, as you can see here from the notes, actually for the gasification, the advantages is low capital cost, so it doesn't take high cost, and also it promotes char or the residue conversion to gas and reduce the volume of solid residue, and also releasing chemical energy contained in char. So the disadvantages of the gasification is it gives rise to low to medium heating value gases, but volume of gases evolved is more than pyrolysis, so heating value can be increased under oxygen, so it enrich the environment. And for the as I told you before, this is the most important thing for this gasification. So you just take out from this notes and write it here. Like you make it a table for you to understand more. As you can see, I just list all the thermal destruction system and take it out what is the advantages, what is disadvantages by using different kind of color of pen. Okay, so you can know that the blue one is the advantages and the red one is the disadvantages, and that's for gasification. And for the pyrolysis, okay, this is the advantages. As you can see here, the advantages of pyrolysis is monomer, oligomer, and organic substances obtained after the process can be separated out or used as a feedstock or for energy generation. Okay, and it also gives rise to high heating value gases, and this is the advantages. And for disadvantages, this kind of process is not suitable for PVC or PVC as HCl or chloride salt, metal impurities, and potentially dioxins is ill. As you know that dioxins of furan or furan is one of the hazardous gases, and it's hazardous gases for the environment if it is released to the atmosphere, because it can give impact to human health. So you need to remember that. And because of it same goes to gasification, you take it out all the information that you think it is important for you to know, to memorize, and you just can imagine on how many slides of this, but you can just make it like one sheet of paper, and it makes you understand and memorize it easier for you. Okay, and then one more tips: if you want to memorize something that is not for this subject only, is for all subject. If you want to memorize something, for example, for the gasification, if you want to know what is the advantages of this process, so it is a low capital cost and promote char conversion to gas. So you need to read and memorize it and say by your own mouth. Say, maybe other people will say you that you are crazy because you are talking to yourself, but just ignore them, and you just, for example, if I want to memorize the advantages of the gasification, so the first point is low capital cost. So low capital cost, low capital cost, low capital cost, low capital cost, low capital cost. You just read and say it 10 times, and inshallah you will memorize it. Believe me. Okay, so that's all. Thank you.
Refuse brought to the plant is weighed and then discharged into the refuse bunker. Bulky waste such as tree trunks and furniture are cut or crushed to small pieces. The refuse is mixed thoroughly in the bunker using overhead grab cranes and then charged into the furnaces from the top. Auxiliary oil burners are used only to start up the combustion. Once the refuse is fired and the furnace temperature maintained, the combustion of the refuse is sustained without the need for auxiliary fuel. The burning refuse is mixed agitated and moved downwards by the moving stoker grate. Preheated air drawn from the refuse bunker is introduced through the underside of the grate. The normal operating temperature in the furnace is about 1000 degrees Celsius. The flue gas produced in the combustion process flows through the boiler to generate superheated steam, which is used to generate electricity. The flue gas is cooled and then passes through a dry lime reactor and an electrostatic precipitator, which will remove up to 85% HCI and 99.5% of the dust content in the flue gas. The flue gas is finally discharged to the atmosphere via chimneys that are 150 meters tall. The ash or residue from the furnace is transported to the ash pit via vibrating conveyors. Ferrous metals are picked up from the ash by overhead electromagnetic separators and sold as scrap.
In this video, we're going to consider the advantages and the disadvantages to waste incineration. What do you think are the advantages of burning waste instead of committing it to landfill? If waste is not burned, then it is likely to end up in a landfill site, which is considered to be the least environmentally friendly option. Incineration could result in a reduction in waste volume of around 90%, and this could be particularly important for small cities where space is scarce and landfill is not an option. Odours and rodents that are present in other methods are not a problem when using incineration as a garbage disposal method. Nearly all of the waste that is burned could be used to generate electricity in what is called energy from waste schemes, where households and industries could benefit from the electricity or heat produced. The electricity generated could help to pay for the start-up cost of the incinerator. Additionally, the steam produced from incineration presents itself as a cost-saving energy source if recycled. Ash produced from these incinerators could be used in the construction and road building industries. In addition, metals could be extracted from the ash, and they could also be used in steel industries. The key advantage, however, is that the production of electricity and thermal energy from waste enables us to conserve conventional sources of energy, such as fossil fuels. Now, what about the disadvantages of incineration? The main disadvantage surrounds potential pollutants found in the ash left in the incinerator and those that could be emitted from the chimney. These include dioxins, acid gases, nitrogen oxide, heavy metals and particulates. As you may have heard from other videos, these are airborne particles which are small enough to get into the lungs of humans. They cause and aggravate respiratory problems such as asthma. However, it is the dioxins resulting from incomplete combustion contained in the gases from the chimneys that attract the most concern. This is because they are suspected of causing cancer. In addition, these emissions could be distributed through the food chains and accumulate over a long period of time, impacting on both ecosystems and human health. As a result, many people are opposed to having incinerators built in or near their communities. Another disadvantage is the initial start-up cost to build a waste incinerator for the production of electricity, and may not be seen as a viable alternative, where cheaper waste disposal methods exist. Once built, the maintenance of the machinery could be costly. The biggest disadvantage, however, is that if waste is incinerated without first being sorted, this means we are incinerating waste that could have been recycled. So, in summary, incineration of waste presents numerous advantages. 1. The energy is used to heat or to produce electricity for homes and industry. 2. This method reduces the need for fossil fuel consumption. 3. The ash produced can be recycled for metals used in the steel industry. And finally, 4. This method reduces the volume of waste produced. There are also disadvantages. 1. Incinerators are expensive to build and maintain. 2. Pollutants in the ash and emissions from incinerators are harmful to health and ecosystems. And finally 3. Waste that could be recycled will instead be incinerated if not properly sorted.
Incineration problem. First, municipal solid waste. Second, causes pollution. Third, variation on energy recovery. Fourth, use up energy. Fifth, encourage more waste. Sixth, moisture from waste. Seventh, sorting.